mathematics up to the level which is necessary for you guys to know. So that's the experience which I got from the last batch. So instead of going too much into the mathematics, we will just keep it to the notion that we understand how it works. So you won't
Okay.
say that this machine learning algorithm is a black box. You would be knowing the decent amount of mathematics for that. Yeah. So having said that, I'll just share my screen. So I
Okay.
quickly take you a formal introduction of the syllabus, which we're gonna see over the coming weeks. Let me share my screen once. And I also make sure that I know that most of some of you do not have any background in Python, but unfortunately here the machine learning algorithm which I gonna discuss that would be in Python, and most of the time in industry we use Python because Python has super awesome community support in machine learning. So I'll definitely take a 1 or 2 session on machine learning, in which I'll share the basic understanding of Python, some snippets of the Python code, which eventually will use you throughout all the future sessions. So if some point of time you are working onto some code, like trying to write a machine learning code, you need Python, you can go to my that repository, you will find how to do that. So this we will take care of that. So anyway, I'll
Okay.
share my screen once. Okay guys, so uh, just a moment. Okay, so how we gonna start in the future weeks? We're gonna have the understanding of introduction to machine learning, which is the target of our today's class. And then we're gonna spend some time into understanding of linear algebra and statistics, which is required to create such algorithms which are required in machine learning. And then we deep dive into the categories of machine learning algorithm. Some are called as supervised, some are called as unsupervised. Once we have a good hold of how what algorithm these are, we would just go a little deep dive into how neural network works. And basically with the relation to deep learning. And then you all have seen that nowadays ChatGPT is more prominent. So what actually brings ChatGPT to this level? So earlier, if you go to 2023, there was just something known as transformers, which was the basic building block of the today's ChatGPT. So that was a package written by one of our scientists, and eventually all the companies use that package to make wrappers on top of that, which is currently known as ChatGPT and Claude. So, and then I'm going to share some case studies with you all, which would be coming from your areas, and then basic assignments projects. So whole learning is not to mug down the machine learning algorithm by heart. It's just to understand that how it makes sense. So eventually the goal after this class of machine learning would be that you would be able to at least able to figure out that this is the objective, this is gonna solve by this machine learning algorithm, and how you can solve that. That I'll make sure that you know that stuff. Yeah,
One request. Can we also touch up upon AI agents? Um, what
definitely.
they are, how they work, maybe.
So definitely I'll plan to take. So that comes under the generative AI. So and now in this, as compared to last year, I think it makes sense to discuss how to use the agentic AI, generative AI into your day-to-day work. So yeah, I'll take the agentic AI as well. Maybe not all, maybe from the open AI or the free ones which you can use coming from Grok, Azure. So I'll take care of that. Yeah, definitely.
Thanks, sir.
Okay. Okay. So okay. Was we sure? Right. So guys, yeah, let's start with the basic understanding of machine learning, and we will try to keep it as fun. No difficult terminologies, just a plain understanding of machine learning. Yeah. So agenda of our course, we're gonna see machine learning everywhere around us. Everywhere we can see some aspect which touches the basics of machine learning. We're gonna see into the application areas. Just a minute. Yeah. What all application areas which you already know that the machine learning has been involved. So until now, I will not go into what machine learning specifically is, and then I'm gonna tell you the basic difference of how it is different from a traditional programming. And mostly you have seen our managers or sometimes super managers. We sometimes call it machine learning, sometimes call it AI. Somebody's call it deep learning. We use different terms. But what actually matters is that what is the thing which differentiate when I can call it an AI, I can call it a machine learning, I can call it just deep learning. So this terminology you might have heard by most of the people around us. So we will at least get to know that how they are different, and then we start our introduction to machine learning. Okay, that's the plan. So guys, I'll just put my camera off. Mm, I am from home. My bandwidth would be saved. Yeah, perfect. Okay. So guys, let's take one by one example. We are using Uber on our daily to daily basis. And if I say you that Uber is running machine learning almost every second, and you know that every second the fares are getting changed. Every second when you're traveling via Uber, via Ola, the routes are getting changed during the way we are reaching from one place to a place. So how it is happening in real time, so and how the numbers are getting changed. So they have not written any kind of if else logic. If something happens, do this. If something happens, do that. No, there's no such logic, and that even cannot be written considering the mass of the locations where the Uber Ola are working. So there are some niche machine learning which is involved. So all such categories of car aggregators, the machine learning is involved a lot. So and it is involved at such a great level that they have the specific whole data locations just working on such use cases. So that's one example where we are seeing the machine learning has been a prominent role. And now coming to the Spotify, so Spotify, so to say, Netflix mostly comes into that area when you started seeing, hearing songs, seeing videos, and after a few time you will start getting the recommendations. Now, if you compare, for example, Netflix and the Hotstar, which used to be there in the last 3 4 years, and you would agree with me that Netflix has the high best recommendations. Now, Hotstar, JioStar, they are also improving and have now quite decent in terms of recommendation. But what makes them different that the Netflix recommendations were top notch as compared to the others. So there are the machine learning based paradigm which is known as recommender systems, which recommends that thing. So earlier, if you remember, when Swiggy, this thing was not there, there used to have some food startup. Tiny Owl was there. So Uber Eats were there. Fasus were there. So I remember when Fasus was started, I worked on one of the POCs for Fasus there. So Fasus have quite using recommender system from a very long time. So so here how you recommend things to your peer, and how these things are getting involved, because you do not know how machine learning models knows that you wanna see this video, and how they do this. That comes under recommender system, because consider the fact that they have not seen you, they do not know your profile. So how they can start making the first recommendations, that all thing matters. So this is where the machine learning has involved. Now the house rentals, now Jalao is one of the house rentals, and but we also have housing.com, all the things. So you see that dynamically the price are getting updated. So how they are able to figure out the appropriate rent into that area. So this all involves a machine learning. And then finally, one of the example is that fraud detection, which basically comes under the category of anomaly detection. That, for example, we are onto some production lines. In fact, here they are getting they're having I mean millions of transactions in terms of supply. The Amazons are doing that, but how they detect that that's a fraud? So what algorithms are running at the back end which detects the fraud, or at least intimate the team? So that's a part of fraud detection algorithms, generally called as anomaly algorithm, and how they are different from other algorithms that we're gonna see that. So just to give you an idea that where these machine learning algorithms are placed, this is some of the examples. Now let's take some of the examples from our companies. We are from some manufacturing companies, automotive. So for example, here, if these chips are not huge, but still if we pass this image into our model, they would be able to detect that okay, there are some weird here, there is a shortage, that's a red mark, that's the heat map. Model finds some issues here, model finds some issues here. So these are anomaly detections in the manufacturing plant. So how we do that? So this generally comes under the category of vision based anomaly detection. So how the model is doing that? So here we see a lot of use of machine learning in the manufacturing plants. uh, Object ADAS is trying to bring most of the cars you have seen, the strings are getting adjusted. The cars are able to detect how they are doing that. So this is one kind of one kind of machine learning algorithm, object detection. Object detection, you are able to detect the object. Now there's something known as object localization, which says that where the object is there. So how so much this is where the machine learning is there. Some of the examples, like this is the recent one, chat gpt's text generation. So if we principally see on a very root level what chat gpt is doing, it is nothing, it's just the probability of the next word. The whole chat gpt, in fact the whole everything is that it's just trying to, it just gives a probability of the next word based on the previous words. That's what a chat gpt is doing at the lowest granular level. But this line of machine learning are generally comes onto the area of generative AI, where we are trying to generate something. If we generate text, that's text generation. If we generate some video, that's vision based generative AI. So we gonna see that. Now, as one of you mentioned, that knowledge of agents. So what agents are? So that we're gonna see. So yeah. So these are some of the areas or machine learning based problems which we see. There are many more, but just to give you an idea where the machine learning algorithms are around us, these are some good examples which I've mentioned here. Okay, and guys, since I am not able to, I'm just seeing this screen. So if somebody has raised the hand, somebody has a question, feel free to interrupt me at any point of time. Uh, so I assume that these things are making sense, of course, but still, feel free to stop me at any point of time. Now, coming up to the application areas, now healthcare and the life science. So it has been said that the next future of the very best use of machine learning AI is gonna come into this healthcare and life science. So some of the example, medical imaging. So now, before 10 years, no one would have imagined that a robotic operation would be done by the robots outside, with no physical involvement of doctor's hand with the patient, and so that's some kind of revolutionary. If you see if you the patients having the lung cancers, the naked eye will never be able to tell that that portion of the there are four quarters in the lungs, that some issue lies in that particular portion. That the granularity of that portion is that it even sometimes smaller than 1 mm. That cells are responsible for the lung cancers, but that things are now pretty well easily getting captured by the computer vision based algorithms. This is the area where the actual, I would say, the AI is helping us. AI is helping us in all the field, but this is something revolutionary happening. I'll also give you a recent example of the chat GPTs. We will not judge on the morality that whether this is good for the customer, actual human being, but now earlier there were customer care decks. Now what I've seen some of the startups have created, they are in fact replacing all the customer care by their agents, generative AI agents. So you call that I want to book an appointment with this doctor. They will take your information, and they are so well trained. These agentic AI, they are able to respond to you based on the question that I specifically want to discuss this problem. What is the next availability of the slot? They are able to look it into the system, reply you, take your feedback. So basically this is talking to an actual human being there. So such systems are also coming into the healthcare. So they are trying to be the first layer of customer care in the I mean all the aspect where the customer text is there. But again, if that's good for us or bad, that's not the point of discussing. But yeah, financial banking. Uh, Fraud detection is the one thing out of these three things where the machine learning algorithms are helping a lot. On a scale over the billions of transactions happening across the numerous numbers of banks, fraud detection is now very easy. So earlier, when you suppose you take some Amazon, AWS, or Google Cloud subscription, and you start doing something of sometimes it happens your account got hacked, not hacked, basically you share somehow mistakenly, you click somewhere and your GCP keys got shared. Then they use your GCP Google Cloud platform to use your computation. Your credit card is linked there, and they will do their work, and your the bill will come onto your credit card. But now if you see recently, the AWS is so well, this experience happened with the AWS, but AWS is so well trained in terms of fraud detection that they will quite quickly know that the processes which is running onto the AWS from your account, that are some kind of anomaly. So that's one kind of detection, fraud detection happening. Also, fraud detection happening in terms of the usage of credit card billings, etc. Also, whether you are a good customer, or you are so in terms of that, you are a performing asset or non-performing asset. If you are maxing your credit card, not paying on time, then eventually you are creating a profile. They run the whole algorithm onto the profile, and then when a new customer comes up, that customer lands up, and if it matches with the some of the profile of non-performing asset, they would be flagged as a possible non-performing asset, and the availability of loan will be decreased. So this is how they use such kind of terminologies into their daily life. We sometimes we heard that make your credit card score, what we call as civil score improve. So actually, civil score is not is just a score which has taken your traits of your transactions done in the past of your every aspect, and then they run it onto the profile of the already trained models, and they see how good you are. I mean, in terms of repayment, and that's what they consider at least. So, and chatbots also chatbots we mostly interact in chatbots during the finance and banking transactions. And finally, coming to, let's make it fast, retail and e-commerce recommended system. I already told you, Flipkart, Snapdeal, Amazon, they all have recommended systems, personalization. So they start recommending things which you like. So yeah, manufacturing plant, this is what area most good to us. The animal detection, predictive maintenance. So for example, the recent kind of a solution is that you create a solution in such a way that you are able to tell preemptively that my this part is gonna gonna scrapped after n number of days. So you started doing the predictive maintenance. So what happened, you are maintaining basically the supply and demand. You are helping the supply and demand to at least figure out that how many parts are gonna fail, how many parts are gonna scrapped in the future. So this area comes under the area of predictive maintenance, and I think this is one of the field where most of the work is happening in the manufacturing plant, where you are preemptively letting them know that this can happen. Taking the data from the batteries, if so we have batteries, we take data from the sensors, and then we do some preemptive analysis, predictive maintenance. Okay, we need a replacement of battery after n number of days. So earlier this was done with the pure conditional logics. Now machine learning is also helping them that if something happens, if this is the trait, how many days the batteries will run or sustain. So, this such kind of maintenance is a part of machine learning algorithms, mostly doing under the manufacturing plant domain. Demand forecasting is one of the aspect where again this is in terms of supply and demand. So normally you have seen that in the manufacturing plant, these plants they are supplying for a massive demand. So they have to be ready. So what they do is they generally keep their supply ready for 1 year, next 2 year. Now consider the fact that if you keep the demand ready for 2 year, and if at the last time the customers back out, then you would be having a splage. I mean the wastage of these many parts. I need battery sensors. I need horns. So if I collect, if as a hella suppose we keep this as a stock. So, but if sometime customer back out at the last moment or they decrease their demand, that would be wastage. So how you can plan this demand in the future in almost in all the plants, all the companies which have their some kind of manufacturing plant, they are doing this demand forecasting. So this is one of the area, and such kind of machine learning algorithms are known as forecasting algorithms, where you forecast in the future based on the current rates, based on the geopolitical conditions happening around you. So for example, if everything was running fine until 2020, 2021 before the COVID arrives, so but suddenly during the COVID period, the demand would have stopped. And that was one of the reasons that Europe is not able to even come to the level in even after 5 years, 4 to 5 years. So things got changed. So their demands got changed. But again, COVID is such kind of activity which could not be even taken care of machine learning because happens once in a lifetime. fortunately. But yeah, so but got my idea. This is how we forecast things in the future, and known as forecasting algorithms. And then transportations is the area, route optimizers, Uber, all the fleets moving across the countries, drivers, they have the fleet management. They figured out the best path of costing them the lesser cost while moving things from point A to point B. Self-driving ADAS. So not in India, but in the future on the dedicated routes, the cars are getting driven by themselves. So they have the route, they have all the plan of over there. Tesla is working on that. We are also working on the ADAS, some of the ADAS level. So yeah, and lastly, not last, but one of the last point which mentioned here is that energy and utilities. I mean, every company want to save the energy, and if they do the predictive maintenance the way we do predictive maintenance into the manufacturing plant. So what they we could have done that we save so much amount of energy equivalent that eventually will convert into the numbers, some money, and then this is what we saved. So how we can do that? So what preemptive steps which we could have taken to save the energies? That's comes under the area of predictive maintenance. So just I tried to cover you a different usually exclusive sets of algorithm. This is not the algorithm, uh, problems which are there around us, and we could have thought these are the algorithm, these are the problems. There are many more, but just to give an idea from different domain, these are the some of the set. Okay, guys. So any issue, any question before going ahead? So mostly just nothing major here. Okay. So
Yeah, it seems clear.
okay, perfect. Thanks. Okay, now let's try to understand a very fun kind of example here: machine learning versus traditional programming. Now take this map. You are at COP technology. I asked you, let's say I'm at Hella office. I asked you to give me the shortest route to reach COP from Hella office in the Hinjewadi as soon as possible. This is the fastest. The condition with you is that there is no traffic constraint. All routes are open. Absolutely no uncertainty. And do you think this is a machine learning problem? So, so this is not a machine learning problem, and this boils down to a simple travels. If you've heard of, there's an algorithm, traveling salesman, in which you can figure out, okay, this is the smallest path. I'll take this path because there is no uncertainty, and uncertainty is the word which always remains with the machine learning problems. So always, if you give a thought that I want to solve some machine learning problem, always thought of in terms of uncertainty, because that's what machine learning is trying to solve the uncertainty. Now, if I say that there are random traffic reflux, you do not know which route gonna close at any point of time. Some BIP getting crossed some of the line, that route is closed on the real time. Now you tell me whether you can tell me the shortest path preemptively. Now we have there are many uncertainties. We have what two uncertainties? There is traffic reflux which could happen at any point of time with n number of regions. Routes may get closed with n number of regions. Now tell me the shortest path. Now this now you see how we move from traditional programming to machine learning programming. So this is where when I bring the uncertainty in front of you, we shifted the problem from normal computer based programming problem to a machine learning problem. Now we gonna train models considering in the past, what was if this was the traffic reflux, if this was the route, what were the open options with me. Models will train on such data in the past, and then they based on such uncertainties they will give you the answer. And always the machine learning solution is not 100% correct. The answer will be the best of the given conditions, given uncertainties. So this is a kind of example, a decent one, where you can clearly understand that how machine learning is different from traditional programming. So just to summary, if every thing is certain, I could just write plain if and else logic. If point A, point B, answer this. If normal if else loop. And but if I started bringing uncertainty, means the knowledge which you do not have. So see, if we do not know some knowledge preemptively, then you cannot judge anything. You cannot give your answers. And you would be uncertain. That's how this knowledge uncertainty, because you do not know what lies ahead. I'm going, okay, I'm going to the airport. My map is saying 15 minutes, so to say, and suddenly there's a traffic flux or something happened which is normally happened on that day, then everything will get changed. So how we counter such kind of mm, uncertainties? There, machine learning, we can solve such problem with the help of machine learning. We can find the shortest route with the help of machine learning given the conditions. So this is an example. Okay, now take one more example here. Now you tell me this example. If this is the graph, a normal sine wave, I guess. If this is the graph, I ask what is gonna what would be the if it is suppose price forecast, what will be the price in June and July? I mean, you can extend that and you can tell me the answer straight away. But now if I tell you there are some irregularities in the fluctuations, as in the market, stock market, there are some cyclicity, there are some trend, or there are some seasonality. So for example, why? I mean, we all know just to make things on a just to start the thing. We normally see the fares got increased in the office time. So morning 9 to 11 fares are high. Daytime the fares is at the cheapest level most of the cases. After and between 5 to 8 p.m. in the night, fares got increased. So what's the reason? Because the uncertainty start coming into the picture. More number of people leaving the offices, and then too much cars on the road, too much traffic. So now we are able to figure out the right pricing, the shortest way. Therefore it makes a case of machine learning use cases. So in terms, so this is the thing which you are seeing here is the is known as time series. I believe you have already heard of this time series based machine learning. In fact, just time series in your past. So this is one example of time series. Here you cannot directly predict. I mean, this is very small level, but if I zoom it, I cannot. If I zoom it, they are even further up hiccups, up and downs in the system. And this is a clearance example, and believe me, you will never see such example of a decent time series in the real world. Okay, so this is another kind of problem where this could have done solved by a time series. I could have created a function y equals to sine x. I can give where x equals to June and July. I get the y, which is eventually either gonna be 0. Suppose this is 100 or minus 100, for example. They're gonna be same. Minus 100 could not be the price, so maybe something 100, 200. Okay, and if the problems becomes a case where in the real time, the future, the seasonalities are coming into the picture. For example, in our new year time, Christmas time, the plants are not running the production at the full capacity. So that's the season, that's some kind of a seasonality. I mean, at that point of time, the productions are bound to decrease in European companies, definitely, because they almost shut their plant off for almost for the last half days of December, right? Now, having said
Hello,
that, yeah,
hello, Raj. Yeah, one question. So, what I understood is the concept of uncertainty is always associated with machine learning, is what you mentioned, right? So we when we have too many uncertainties, then uh, it will be like a machine learning problem rather than a programming problem. Correct?
partially,
Hello.
yes, yeah.
Yeah.
Till now, yes, what I've
No,
said.
yeah. So now in mathematically, if I say uncertainty means it's the variables. For example, we have some regression problems which we were trying to solve. Uh,
Yeah.
it, we
Hmm.
have many variables which we have, and what we try to do is we try to find out the best function which will solve it, and then that will be predicting. So when we try to make the difference between a traditional programming problem versus machine learning problem, so
Hmm.
is there a limit on the number of variables which will say, okay, at one point this will be a traditional problem, and then the other point it will be a machine learning problem.
Okay, so I
So
got a question.
yeah.
Okay, so that is it, right? That's the one question. Is it?
Yes, that is one question. So
Okay. Hmm. Okay, so let's answer this question. So one term answer, no, we cannot do that. There is no fixed limit of variables because uh, yeah, I'll come to the in the next slide. There's no fixed limit of variables when you can say this is a machine learning problem or this is a computer this is a traditional programming problem. Think it that in a way, if you're trying to solve some kind of problem which has a lot of uncertainties, then when you are saying there are a lot of uncertainties, that by itself suffice that you do not know what's the knowledge. You do not know you're gonna solve by 10 variables, 20 variables, 50 variables. For everyone, variables means any kind of pointer. For example, if I am going to predict the weight of us, that's simple example. Then if I know an height, I know the VMI index. One more variable, you can tell my weight. So here, when he mentioned variable, this is what he want to mention, the future. So so based on some future, you can calculate the y variable, which could be anything. So here, if the question was that if there are some fixed limit that if I know 100 variable, we can solve it by machine learning, or if lesser than that, that's a traditional problem. So no, because uncertainty is something which you do not know. And if you do not know something fully, you do not know what are the latent hidden variables behind that. So I'll come to that point. For example, you are trying to solve some data points which are abruptly spread in your data sheet. So for example, today I do not have my pad. I'll bring it in the next class. So suppose this is some xy chart, and there are some data points, numerical data points that are spread somewhere. Now, if you know already there are some functions exist in the universal mathematical space, you could use that functions directly. So that's the traditional programming functions where the functions are already being created for you. Sine wave, you know sine wave. But suppose you try to bring up some function y equals to something, theta x1, theta x2, theta x3, x1, x2, x3 are the variables. You do not know how many variables to be taken. Still, you are not able to come up with the actual function which covers all the point perfectly. So that function doesn't exist. So that functions will eventually turns into a machine learning based problems. And this, so just be with me here. Just take us to this slide, and things gonna understandable now. So come to the traditional programming system. Traditional programming system, you are creating some system, anything. You have the data, you know the function, and so suppose I want to create a sine. I am just taking a very simple example. I want to create a sine wave simulator. As the name signifies, it gives you a sine wave. That's it. That's my application. Suppose startup in a some happy word that people pay me for creating a sine wave simulator. So I know the function which is a sine wave. I know the data could be anything which user provides into the UI. I give them the output. So that's something which is already existed from the mathematical perspective. So that's a traditional programming. Now coming to the point, some company have given me the data and tell me that figure out this output. Now let me tell you an example. This data is that they have given you the prices, for example, prices of the house of complete India wide, all the locations, all the localities, localities and their price of the flat. They have given the data structures that this flight, this flat which already existed there, just be with me, that has that many number of rooms, that is the square feet size, that's if balconies there, how what VHK 3 BHK 2 BHK, and hundreds of variable. Now tell me, is there any mathematical functions already existed which takes this data? This data can be 100 variables, 200 variables, you never know, and
No,
which
yeah.
you have the price. No, I mean, now tell me one thing. If I give you 100 variables, now can you say that even more knowledge will not help to find the best price? No, more the information, better is my system. And what happened here, based on this data and based on the output, you create a machine learning algorithm which gives you a function which we called as not by y is something y equals to sine wave. This function is something called as y hat. So basically a machine learning algorithm, machine learning based functions which we created, which helps to forecast or predict some value. So this is a very clear cut understanding of difference between traditional programming, machine learning. In traditional programming, you already know system means you already know the function which has to apply, you know the data, and you can do some output. So if, again repeating my words, if there is no uncertainty, I can write a function. Normally a function is C, C++, Java, Python. If this happens, do that. If this happens, do that, and so on. Even some complex functions. So just, and then we make, and when we take the value and we got the output. But here we have the data and we have the prices. Now they tell me create some system using machine learning Why which in future a new customer comes into the machine, my application, my startup, they give me, okay, this is my requirement, I provide them the best prices. So this is where machine learning based on the variables, futures, just they are same thing, variable of futures, we and the output price, we give them some solution. So yes, so this makes your answer that there is no fixed limit on the variables. More the better, of course, keeping in mind if the more are bad in nature, that will eventually break our models. So that we're gonna see. If some feature are good, we take it to make the focus. And for on a layman term, so for example, suppose if you want to solve any of the problem, and for example, if you earlier than Google Map, how when we used to traverse from point A to point B on a longer journey, maybe 400 500 kilometers, after reaching some location, when we want to reach some unknown location, we ask people, and when two or three says that okay, go straight, this increases your confidence. So generally you ask one or two people, if both says that okay, go straight, take a right turn. So eventually you get two data points from them, that makes your belief or confidence higher. Okay, I have to take right turn, and then you go on the right turn. So basically what happened, you get two data points from here, output, right turn, and then your system decides, okay, this is how you should do earlier. Now same thing, just an ideology, same thing is happening in the current world. When we have the data, we have the output, the known way, the system says, okay, do this. So we create a system. So keeping it simple, this is a simple difference of traditional machine learning, where if we know already there exists some mathematical functions which could help, and there is no uncertainty, we could easily solve that. So that's a traditional programming. There's no need of going to the machine learning. But if even after looking into the data, understanding the objective, we cannot create or find any function into the universe, then machine learning could be one of the way. That is the way, not sure, but could be one of the way. So does it make clear? I mean, at this point, I definitely want everyone to be on the clear before going to the next class, that how they differ. If somebody asks you why it is not, it is, why it is a traditional programming or machine learning, you should answer, right?
Yeah. Hello.
Yeah.
Yeah. Like I got this part regarding variable, but there is a one more maybe linked question regarding this
Yeah.
variable. So, like let's say maybe right side you have shown that block diagram. So here we are saying data and output as a feed to the system.
Yeah.
And data means we are giving some explicitly some variable. Let's say like I have system c is equal to a
Mm-hmm.
plus b.
Mm-hmm.
So like maybe these are a and b are like known variable to me. That
Yeah. Right.
I'm
Yeah.
thinking that those are going to affect on my c. But
Yeah. Right.
if there is a maybe there is a some d variable that is also going to affect, but I don't
Mm-hmm.
know at this point of time. So
Right. Hmm.
how this machine learning is going to take care of that phenomenon? Means if I
So
am unaware about some kind of
yeah.
variable, so
Perfectly. I mean, a very good question. In fact, if you ask, that's kind of very good question, and I want everyone to understand what he has asked. So basically, he asked. I'll just write it into the Y form. He knows that I know when I try to solve the problem. I know that my problem is something like m x1. I mentioned it x1. He mentioned a b c, and m is same. Some coefficient. You always say this is how the equation works. And now there's one more. I'll just also do it. Let's say it n, uh, mx1 and x2, some quotient. Uh, if this is known, x1 x2 are two variables. I can easily solve this problem. I know that thing. But now, what happen if some variables again come into the picture, m and say n1 and 2 x3, let's keep it same, and 3x3 plus and 4x4. How machine learning takes care of that? Okay, so now for everyone, x1 x2 is what? I'll give you a very good example here. Number of houses, I'll just it's easy to understand thing if I relate it to the some real thing, which the x is the number of houses, square feet, just keeping it to one more. Let's say is balcony available, is balcony, so how many balconies, just keep it numerical, number of balconies, right? And then output variable y is the price. number of houses matlab BHK. There's that 1600, three balconies, perfect, a very known set. Price, let's keep it say rental prices just to make numbers smaller. 10,000 rents, right? Now eventually you would agree in the post locality the same variable would be charging 70,000 rents, maybe in KP somewhere, some political areas. Now you say that this numbers are same. The same equation would have given the same would have gi- should have given the same values. Now what is missing here? Now what you have missed. So can anyone tell the one word answer? What is missing here? The thing which is missing here is that uncertainties. You do not know what are the variables x4, x5, x6, x7. They could be many things. Now even if I would have bought just one location area, suppose just suppose this is KP. This is some village in the Pune, some village near Mulsi, for example. I mean that would be, I do not know the price of there. Even this information, this is some information which brings some more confidence, of course. So now these are four variables here. Now there could be 100, 200, 50, 20, 30 variables. So more the information comes into the picture, more you would be able to calculate y. This is one thing. Now coming to your actual answers. So now our goal is, I mean, now what happens generally, such informations we take that is coming from the business objective, and we got such amounts of data, and say we got such 1 lakh of data inputs. When I say 1 lakh of data inputs means 1 lakh of data points having these configurations, variables, and the y value. Now we will create a machine learning solution like this. Now your question is that how we gonna find the appropriate. I will not say the actual, because if we know the actuals, that would be a traditional, because we knows everything. So what is the right word? The appropriate or the closest one. So this is what we need to find. And 3 and 4, these variables. How we gonna solve that? So this area specifically comes into the area of regression algorithm, regression problem, where you having looking at this data. On this data you find the best set of, model will try to find the best set of vari x1 x2 are the variables, m n and 3 are known as coefficients, and these are simple mathematical terminologies. We will find the best set of coefficients which makes our predictions are known as y hat. Actually cannot draw it here. It is y hat is nothing at, hat is a normal terminology in the machine learning world. This is some kind of predictions in which we find the best set of coefficient, and goal is to be that our numbers, for example, should be closer to the 9,000. This is what machine learning will try to do it. How we do it? Finding the best set of coefficients. If it is 100, even finding the best set of 100 coefficients. How we gonna do it? We gonna do it using machine learning algorithm. What machine learning algorithm? Just for an example, do not need to just mug it. It's regression problem. This becomes our very first lecture. First lecture after this introduction, how to handle the regression problem. So once you understand the problem, we're gonna solve some of the use cases, actual code, and then you would be able to handle all kind of machine learning problems where given the variables you would be able to find the predictions y hat. Now in this example this is prices. In some of the examples it could be anything. I mean where the numbers are numericals. You want to predict something, right? So yeah, so does it answer my question that how when this variables start increasing x5
Yeah.
x6,
Okay, so
but
I got your point. So you're saying that those coefficients will be adjusted to best possible extent,
best
and
possible, perfectly, yeah.
that are but
Our machine
maybe
learning algorithm goal would be
what
to
I
find the best
understood,
set. Yeah, yeah.
yeah, but what I understood next that the uncertainty will be more in this case compared to where we are having more known variables. So that part will be remain attached to this model, correct?
Yeah, so more you increase your variable, and when I say more, in terms of more good variables. Now for
Mm,
so if
mm.
you So just thinking the example of if I give you if you get more input from the people toward the direction you want to reach, you get the more trust. The same
Yeah.
ideology, the more the information, the good information. For example, I'll give you an example of bad information which will not help. Three houses, square feet. If I create a variable, average, average house size, average house size, average house size, no, average room size. This has to, the right word should be number of rooms, 3 BHK. Average room size. If this is the variable, I I mentioned this is 1600. Of course, simple mathematics, 16 divided by 3. So I added one variable. Now whether this is helpful for machine learning algorithm, no, because already you have this information getting covered here. So this is a
Mm,
useless variable. This will not help me. So adding that, in fact,
okay.
even adding that makes the model bad, because the effect of
Yeah.
these two would be multiplied with this, because q1 associated with coefficient associated with this again added is plus sign. Some coefficient will add this value as well, so your y hat would be inflated. So this is bad. So this is a
Okay.
simple example. So we would learn in future when I learn regression problem, that how to take the good variable, how make our machine learning understand that which variable is good. Simple example,
I
because
guess
yeah.
yeah,
Okay,
maybe yeah.
so
I'm
hmm,
okay at this point
perfect.
of time.
So
Yeah.
yeah.
Yeah. Thank you.
Hmm. So if so when you ask question, I'll
Sorry,
try to relate it with the things. Yeah, please.
just to extend this question, what I understood is, just correct me if I'm wrong. What I
Yeah,
understood is, what machine learning does is, it will not give you number of unknown variables in your equation, but it will try to predict the behavior of all the unknown variables along with its coefficient to give
that's
you
right.
a closest result
Closest.
possible. And if
Right.
the more the number of input we give to the machine learning, it will try to go as close to the perfect output,
Perfect.
right?
Perfect.
Okay.
And always say more number of variables which I give to my objective. Those variables, if in hindsight, in the latent, has a good relation with the y, that will improve a model. Now see, in general, this you now know. Now we always write machine learning algorithm. They are always C. C is something which we do not know, coefficient. Now why somehow you get one variable? So what you did, you take some known part out of x, that would be called some, say x5. Now that would be c dash. So you mean what I want to say? This information, a good information, you taken out from something which you do not know. So from uncertainty, you bring something out with the help of knowledge, right? And knowledge always comes more with the number of more futures, also with the number of more data points. You just give me say 100 futures, just 4 variables, my model won't be able to train. So I need also a good number of data points. So that's why you would have heard that the data is lesser. Sometimes data is lesser in terms of the futures, sometimes data is lesser in terms of the data points, right? So this thing, now again we will see which algorithm works best. And when I say best, this is always relative. No algorithm is best. It's always relative. So by best means, uh, given condition, which algorithm works for me. So that's why in the machine learning, when you write code, when you solve problem, you try most of the algorithms which are suitable to solve this problem, and then you take the best out of the one which performed best on the evolution side. So generally what we do, we create some models, we create some keep some data for buffer to evaluate our models, and then we see, okay, suppose there are two models, am1, I name it am2, right? There are some the actuals means actual price was something, say this was the actual price 10,000. This model says 7,500. This model says 8,000. So just for one data point, 8,000 price is more closer to the 10,000. For this data point, M2 works well. Over 1,000 points, which was there in my evaluation data set, I see which works best. And eventually, if I decide, okay, M1 was the best model. So we try different sets of model. Eventually, you will try with one model. Then you will try different set of models. And then you finally decide, okay, this is the model which works best. So therefore, we do many numbers of iterations. But yeah. Surely, first thing first, you will not try all the models. You will try only those models. When I say models, I might use sometimes the word algorithm. So machine learning functions. So by that I means the one which is definitely able to solve such problems. And there are many problems which could not be solved by regression. So I will never use regression. Regression never able to solve the problem where you decide class A, class B. Okay. Now, for example, there is a rainy day, there is a sunny day. So regression will not solve this problem. Some different kind of algorithms. So this we're gonna see in the future. If you remember, the thing I shown you here, that supervised, unsupervised, we're gonna see into that. I'm not so yeah. Coming to the syllabus. Okay, I think now most I have cleared most of the points. Coming to the Excel, yeah. So anyone and so I hope by that point of time you at least understand where the usage of traditional programming lies, where the machine learning lies, and also the concept of uncertainty. That's very much important, and also the fact that a good model craves for a good knowledge. If from the data, from the business problem which you want to solve, some company, any objective, if we are able to take a good amount of data, then our chances of coming up some function y hat would be more closer to the actuals. So that's our goal. So as rightly mentioned by you, that our goal is never to find, or you will never be able to find the actual. You would be able to find the adjusted or the appropriate coefficients based on the data, and that's our objective. And that's its fault. We are training the models. So you have heard this term a lot. Train your model, train your model. So when they say train, it in the terms of regression, it means find the best set of coefficients. So uh, do not take machine learning ever as a some kind of uh, super god thing. No, it's just plain mathematics. It's mathematics. Everything is mathematics and the probability and the stats. So most of the thing, which is as it is done by the statistical, even 50 years back, which is now sometimes called as regression problem. But the background is stats. Even when you're gonna learn this problem, you will see the background is stats. That's why one day we're gonna see basic understandings of linear algebra and statistical knowledge. Eventually that will help you in many of your non-machine learning use cases definitely. Okay guys, so if this is clear, let's do it this way. uh, it's almost 8:30 and this is 2 hours class, so let's take 5 to 10 minutes break after this slide. Whatever you say, normally 5 minutes would be fine, but yeah, up to
Yes.
you. You we all have done offices and this class. Okay, now guys, coming to uh, this is the one thing I want to focus you all here. I mean, I know that this is an optional class for each of us, but we all just try to make use of this class as because the content which I gonna use, that would be up to the standard that it uses in the actual machine learning batches of actual MTech classes. So we will try to keep that standard, but yeah, whatever is required till our level, that would be the goal. So from next time somebody asks what the machine learning artificial intelligence, you will be able to answer this slide. Okay guys, so as I mentioned, artificial intelligence word is used by a lot. Managers generally use artificial intelligence. When it comes to us developer, we called it, we are solving this problem via machine learning, and then we deep dive. So artificial intelligence is the psychology. I mean, this is something new word which you might be heard from me. Artificial intelligence is psychology. Basically, how you are trying to solve this problem. So there are two normal niche of solving a problem. You know the thing is there in front of you, being done by the people in the past. You solve that problem. That's the no, that's the intelligence which is existed in the universe. When I say universe, it means the whole world. In the past, you solve this problem. That's not now the something, the some problem which was never existed in the past couldn't have been solved by the normal intelligence. As the name says, artificial intelligence, went your information some way and you created some solution artificially. So that is known as artificial intelligence. So artificial intelligence is not a technical word. It's the protocol or the way we solve a problem. So we solve and machine learning, deep learning, these are the ways of achieving the artificial intelligence. So for example, we earlier we do not know how to find a best route going with the with the unknown variables. If you started driving here to say the people do drive from till Europe, I mean, we cannot even imagine how what uncertainties you are. Even if you even ask you to write some code where you can just figure out, okay, and I will land China and I will land Nepal, China, then Europe, Kazakhstan, via Kazakhstan. That's the route. So I will land at that day, at that point of time. You cannot write that function because that has a lot of uncertainties. Now I want to solve this problem, which was not solved earlier. How we will solve? I will collect the data of the people who have done this trip going from India to Europe via car. I, that's intelligence I'm gonna take from their experience. So therefore, that's the right word of introducing the experience here. Machine learning algorithms or the artificial intelligence are created based on the experience which are acquired in the past. So in the book, there is a book written by the Tom Michel. Michel says that if I learn some experience and I am able to solve a problem which was not solved earlier, and if my way of solving the problem improves the way I solve the problem, I have achieved artificial intelligence. So by that I mean to say that by acquiring the intelligence, you solved some problem which was not solved earlier. That's artificial intelligence. So that's a word, not a technical word. It's just an overall protocol, the ideology, psychology. Ideology is the right word of solving the things. How you solve that? We solve it using some technical way of doing that, which are known as machine learning. So always, as a developer, when you say when you are discussing with your peer group, with us, you are solving problem, you are basically doing it via machine learning. But when you present it to someone in you created a startup, you everyone we heard that we said AI startup. We sometimes we see machine learning startup, but on a on a tech trend search paper, you always read AI startup. Nobody said Gen AI startup. Now Gen AI still looks cool. Deep learning startup, machine learning startup. Because people didn't the people at the higher level, uh, how you solve that doesn't matter. You're solving it using AI. So that's at that level. Our level, being developers, this is where the thing lies. We are solving problem using machine learning. And machine learning, then we there are something known as deep learning, which is the neural network you have heard of. Inside that, if we solve problem onto the images, videos, that is vision based, computer vision based problem. If it is terms of chat GPT, GPTs, that are large language models, part of deep learning. So deep learning is a small subset of machine learning, a small subset of machine learning. How we do that, and then artificial intelligence is the ideology of solving that thing. Other than that, I have created a bracket, and again this is created by me, so I'm not sure somebody put it inside that, but that's my understanding. There's something also known as CV and image processing. I have keep it far because computer vision and image processing, when machine learning were not came into the existence, it was it was doing via the classical image processing written in the C++ programming. So even if you go to the OpenCV package, that is earlier that was written in open C++, and they were doing all the digital stitching, all the thing via normal mathematics. So therefore this set is outside. So computer vision problem can also be solved via normal image processing, digital image processing. Therefore you see this structure. So this is the complete sphere of how the each term lies. Right, so okay, if this is I mean, take your time. I'll share the slide by tomorrow, and then you can have a look. And yeah, so I think that's we almost finished up on the time. This was supposed to start on the 8:30 sharp. We did it on time. So yeah, so I think guys, if no question, if anybody has any question, let's discuss this about this pie chart, not pie chart, just a chart. And if no, we meet at 8:45, and then we're gonna start the formal introduction of machine learning. So yeah, guys. So I
Okay.
think so far what I've seen that at least making sense. I mean, so I do not want we to mug everything. We just want to keep the principles, at least the fundamentals, very much clear by the end of this course. So yeah, let's okay. Then I'll just put it myself on the mute. Let's keep it open, and we meet at 8:45. Okay. See you
Yeah,
guys. Yeah.
sure.
Yeah, hello guys. Just let me know when we
Ye-
start.
Yes, I think we can start. Yeah.
So, okay, guys, assuming whoever on the mute, you guys are back. So yeah, really sharing my screen. Okay. Okay. So coming to introduction to machine learning. Let me check if my is on. Perfect. Okay, so we will reiterate with where we finished, that the right part of our chart comparison between the traditional and the machine learning. Machine learning, again, a subset of artificial intelligence that focuses on the development of algorithms and the statistical models. Basically, that help us to learn patterns and the relationship among the data. So relationship among the data, the futures, variables. So things are already sorted now. You know that when I say data, I mean a data point where we have the futures, variables, we have the output, for example, the prices, and without being explicitly programmed. So this word is very much important here.
અને
We
lecture
never hello.
કરવું પડશે પેલો ઉઠીને સાંભળી લે રેકોર્ડિંગ કરી
Let's get just it's okay if you put yourself on mute. Okay, so without being explicitly programmed. So now you got my point. We know the data, I know the output. I'm not going to write the code as code. I mean the whole program by ourselves. If something happens to that, something happens to that, we even cannot write if we can write some possible cases, because we do not know all the things that could have appear now in the future. So basically the uncertainties, and we do not know whenever we would be able to find all the knowledge certainties so that we can write the code. In such scenario, we use machine learning, and that's what our machine learning is, how the machine learning is defined. Given the data, given the output, by output means the thing which we want to predict, we create a machine learning based algorithm. Using machine learning based algorithm, we create a solution which generally gives you a function. When I say function, a program, in terms of our discussion, y hat, or a possible best set of the coefficients that you can use to do the prediction in the futures. So now the line taken from again Tom M. Mitchell, a computer program, basically the function is said to learn from the experience E. Experience E means the data in the past based on some tasks, the problem which we gonna solve, finding the best rental prices, and some performance measures P, how you evaluate which model is doing better than other. If it is performance on T, basically the task increased by some measure, we say that we have gained some knowledge, the experience, and that what machine learning does. Machine learning helps you to find some program which is after training able to give you a predictions which they roughly tends to be, the right word should be closer, tends closer to the actual predictions. So if you create some system, this is a startup finding the rental price like housing.com. I as a new user, I put some query, I can get some predictions from them, and then that should be closer to the actuals actuals which was there in the data. That's the idea, and that's the machine learning is that. So you will not write something totally programmed. You will create some algorithms which will learn, which will try to find all the patterns, relationships, but not all, whatever they could, given the data and the output. So I hope this is clear. So now this looks clear to me because the questions being asked by you in the previous 1 hour, when you asked about the best coefficients, how to find that. So when I say finding the best coefficients, that's for the regression problem. Now, as the machine learning algorithm changes in future, there are many algorithms that things will change. That what we find, there will always be such some coefficients or something which we are supposed to find. given the data and the output. Okay, so this is what machine learning is. Let's decode this example. Again, I'll bring it to a smaller level. Uh, I work in zoo. I work in some zoo. I'm a new intern. I've been asked. I always try to keep some funny examples just to make things very easier. I cannot recall. I mean, if I do not know, I'm a new intern. I do not know what are the categories of these cats. Now there are three examples. Being a pattern the veterinary doctor. I think they are called as veterinary doctors. The doctors of animal, they are supposed to know these. If I'm specifically a cat specialist, I should know all the cats, all the dog. So I cannot say which one is which. Now say if this new the guy who are gonna replace who are being replaced by this she told her that okay, the first one is the Persian cat, this is a Siamese cat, this is a Egyptian cat. Okay. Now again, what happened? Now suppose these are 100 cats. Now this person asks to this person, okay, which cat is this out of those hundreds, which was shown to her once. Now she is like that. I'm still not sure. This could be a Siamese or this could be an Egyptian. Now what happened? This doctor again give him the example. Okay, now see these many cats. These are the Persians. These are the Siamese, and these are the Egyptian cats. Now tell me which is this. Now she would be able to tell. Okay, now I get this. This is a Siamese cat. This one. So what we learned from this example. Now do one thing. Replace this person. Replace this person by a computer program. The computer program which looks onto the image and try to give you the answer. So earlier the computer program was shown with these examples. The computer program was asked some unknown example. The computer program was not able to answer. But then computer program was shown these many examples. They learned the patterns. They learned the patterns. Okay, these cats have the blackish face. These are dotted one. These are the furry one. So this is some kind of pattern in the data. Computer program learned that, and then computer program was able to answer. So this is one kind of machine learning algorithm where the program, computer program, this new intern able to understand what is the object in it. That's the object detection, specifically the categories. So you got my point. Example of machine learning. So this is how we provided him the more knowledge. These are the knowledge. If this is just three. We'll consider 3,000 many until the knowledge until we stop using the knowledge. We provide them more knowledge than she or the computer program was able to understand. So the point is that even the human nature, when we get more knowledge, we are more confident and we are able to do the same thing, do the things whatever it is. So the same thing, the same ideology has been trying to be incorporated into the machine learning. More the knowledge, understanding the patterns and relationship among the data in with the help of that knowledge, we create a better machine learning models. Okay, so guys, this if this funny understanding is done, let's come to the type of machine learning problems. Okay, so now in general, there are even more ways than three, but in general, in fact, most of the machine learning algorithms are bifurcated or basically a part of either one of these. They are mutually exclusive. The one which is unsupervised cannot be supervised, right? At least in these two. First one is known as supervised machine learning. Another one is known as unsupervised. Third is reinforcement machine learning. So before going to the into the detail, supervised machine learning. As the name says, supervised. When we say supervised, it means that your whole machine learning model understanding, finding the patterns was supervised. When I say supervised, you were given the data. You were given the data like the price, housing prices, number of PSK, square foots, whether it has balcony, all the n number of variables, and you were also given the ground truth, the actual prices. So such kind of setup where you are provided the data, you're also provided the ground truth. So like ground truth is the term which is required here. Ground truth, you know, all already know the actuals, the actual truth. In the actual truth of based on the data point, this is the actual truth. So if you are provided with data, actual truth, and you create a machine learning model on that thing, the basically the same which we see in the slide where we have data, output, system, we devise a function. Those kind of problems are called as unsupervised machine learning problems. right? So there could be the cases, given the data, you have to predict whether it will rain, whether it's gonna be a rainy day, it's gonna be a sunny day. Just an example, it's gonna be a say cloudy day. So here you also classifying. You know the data, you know the output. That's a supervised machine learning problem. So if I somebody gives you a problem, gives you a business objective, you are able to find the data. You are also able to find the y actual values, ground truth. You can straight away reduce that. This is a supervised machine learning problem, right? We will go in detail one by one. Unsupervised. When you have given the data, you are not provided with the y. So let's not go in the unsupervised. Go into the supervised directly. So when I say supervised machine learning model, here the model is trained using the labeled data, basically the ground truth. This means that for each input, the correct output is already known. So for the data point, given the configuration of some data point in the price rental price problem, you know the known price. So you have given the correct output. This information and the data is provided to you. That is the one of the region, one of the point which says that that's a supervised machine learning problem. Labeled means that that number is given to you, that number actual numbers. Now what model does, models trying to find the patterns. So find the patterns means mapping input to the correct output based on this data. So they will try to find some appropriate relationship among the given data and the output. Why? And this way the model try to learn, okay, if this is the data point, if this is the locality, this is the price. If this is the data point, this is the price. So all the x1s, x2, x3s, x4s, xn's are provided. Model every time model will try to find the best coefficients q1, q2, etc. And after achieving this experiment, this training, after say 1,000 iterations, we models would be trained. Models output would be a function, a program y hat, which is a predictions whose goal is to find the nearest, the closest price based on that configuration. So again, simply, so house price prediction. You are given data, you are given output. That's a supervised. Email spam classification. Given the email, you have also given the data that that's a spam. For example, even some email reads, you have won lottery XYZ, please deposit 10,000. You have also given the in the data, you also given the output, that's a spam. Hi, this is some job requirement from Naukri.com, non-spam. So you got this data. So this problem is a supervised machine learning problem because you knows the data, you know the output to train your model. Customer churn prediction. This is the profile of customer, whether he will leave whether he will leave. I mean by leave means will not make another purchase. Employee attrition. Given the data, this employee left the company in next 1 year. Given this configuration, 3 year guy, uh, these many previously, so it's 4 5 companies. Just trying to give you some data points and leave the company. This is the data. So this human resources based problem, employee attrition problem. So whole crux is that in all the problems, this is supervised machine learning. Why? You know the data variables, you know the output. So guys, any problem, any issue in supervised machine learning?
No, Raj, I think it's
No,
clear.
it's clear. Yeah.
Okay,
Yeah.
thanks guys. Okay, same. Now all now this thing is discussed so many times. Given the attributes, now let's understand. We call them variables, but we such data is known as independent variables. Even your y is also a variable. I mean y. Everything is variable. But the right terminology to denote the futures are the independent variables, sometimes known as predictors because they helps you predict the values, many times known as futures and attributes, properties. Everything's the same. But if you say gonna say it variable, these are independent variable. Why? The house price, that's the target variable, the target, the target, the thing which you want to achieve. Also known as dependent variable, response variable, target variable. You can call it whatever. Ground truth is the best layman term. Ground truth labels. House price is an example. So these are the two terminologies, right? Customer default predictions. these many could be the attributions, even so on. Age, salary, is married, number of family members, loan years, loan amount, past numbers of premium paid, how many faults happened. Out of 36 premiums, 4 were faulted. Max days with fault. I mean, I didn't pay my due for n number of days. That's one feature which decides whether I am going to default in the future. And this is how, banks perform the analysis of non-performing asset. But they are the features are very well described by the financial researchers, audit guys. So these are the attributes, and this is a ground truth variable, right? So yeah, this is what supervised machine learning algorithm is. If somebody gives you a problem, you ask, what is the business problem? Okay, this is a business problem. Okay, how the data looks? They see, okay, this is the data. Do we have ground truth? Yes, I do have ground truth. You boiled down your problem to a supervised machine learning problem. Now you gotta think from now on, what algorithms comes under the supervised machine learning problem. This is how you curtail down and to the best algorithm, right? Now coming to the case unsupervised machine learning problem. So see what happened if we got the data, but we do not know the labels, the outputs. We do not know that. So how we gonna solve these problems? So such kind of problems are known as unsupervised learning, right? Where you have the data, but you do not know the ground truth. So these problems are known as unsupervised learnings. So how the model, I'll give you some examples, but how the models understand or learn in this scenario, they will look at the data and then they will try to understand the underlying structure of the data. So I'll take the example, but just to summarize, unsupervised means you won't be provided with this ground truth. There would be no ground truth. You would be having this data. That is it. The same problem, customer default prediction problem, could be solved in the unsupervised way. So for example, I am the customer. I asked you, customer, I mean client, I used to create a customer default prediction solution for me, but I told you that, see, I cannot share this ground truth with you. I have only this data. Now you cannot say that, okay, we won't solve this problem because you do not give me ground truth. The problem now would be shifted from supervised to unsupervised because this thing is not provided to you. Therefore, unsupervised machine learning problem. There are lots of machine learning problem, machine learning algorithm that's a part of unsupervised one. Some example here: grouping of customers based on their spending profile. So normally, how banks, not banks, any company generally you have seen that they give coupons to people, 500 coupon or 20% off for the new customer. So what they do based on their profile, they segregate their customers based on the profile they have. I mean, if I am visiting Amazon, you are visiting Amazon, you already given them the consent to use your data for there, and your data is getting used by everyone to find to create their models, understand. So what they do, they collect data of us, and then they create a unsupervised by unsupervised they create some clustering sort of thing. Okay, this is the group of customer who are our best customer. Okay, right, this is the new one who have recently joined us. This, there maybe just maybe three categories. There could be n number of categories based on the problem they are going to solve, but suppose there are three categories: the new one, the best one, and they are the middle ones who basically like me, like us, who jumps from Flipkart to Amazon based on whatever gives us best. So how to, keep them with Amazon? For example, as a Amazon machine learning model trainer, or as a Amazon, how what should I do? So first thing first, I try to figure out the group of customers, and then I target them specifically. New V's. I will give them the first time coupons free, that like the Uber used to do earlier. New customer, flat 20-30% off. And then best customer, let's not deal with them. They are loyal ones. They stay with us. So, but how you group them? That's the unsupervised algorithm. We're gonna see that. That's definitely one of the algorithm which we're gonna see that. That is known as clustering algorithm, in which you cluster the profiles groups based on the problem you're gonna solve. Anomaly detection. Now this is interesting for every one of us. How in the real time, practically as a fact, we see anomaly happen on a regular basis. If my part is going onto the conveyor belts, hardly after say 100 parts or 200 parts we get suppose one bad part. So never in the case I would be able to or even our problems also get changed. Sometimes there are sometimes error happen, or maybe say on the right bottom of the PCB board, sometime on the top left, sometimes some registers got short circuited or some part. So we never know the actual images. Even if we know that amount is very lesser of the actual ground truth. I'll use the term ground truth. So you cannot use supervised in most of the cases. So how you go in that direction? So anomaly detection. So anomaly detection is the classic example of unsupervised machine learning algorithm, in which you create a model based on the good images, and good images we have a lot of good images. Just put a camera, properly focus camera, and collect the images on the onto the conveyor belt and create a model. Now suppose when a PCB board which gets some anomaly passes to that machine learning model, that model flags that part based on the good futures getting we the model got from the good images. So suppose we create 2000 parts, we took images of thousands images from 2000 parts, we create some distribution. Now one bad image, bad part start passing on the conveyor belt, my model will flag it because the distribution of that part would be different from the data collected from the ground truth. How we do that, that is we're gonna see it later. But again, my point is to understand you what is unsupervised. So this is one of the examples of unsupervised. You do not know ground truth that this part is passed, this part is failed. You do not know that. You just know that that part has passed from the conveyor belt. You do not know the ground truth. So unsupervised one. One more, and this is recently very much coming into the play, reinforcement learning. So do not get mistaken by the word agents here. It has no relation with the chat GPT agents, no Gen AI. This is proper agents mean system. So what happened in that, you make the system learn based on the behavior. So for example, suppose you are creating a some game. You how this you play chess online. So they are computer, even many games, they are CPU on the other side. They do the strategy. Earlier there used to be the fixed set of steps, but now even that CPUs or the opponent on the other side, which is a computer, basically they are trained via the reinforcement learning. They know what move to make when you make your pawn move, or somewhere you make a bishop move. So that's some steps. They know when to take the best step. Now how they learn that? They learn from the strategy. So for example, self-driving cars, how they learn? Suppose we have to take a right turn, and if my take car, the self-driving car takes a right turn, so we will reward them. So there's a term known as reward. So reward and penalty. So when you do good, we reward you. When you do bad, we give you the penalty. And now one very fun example, which you can even search onto internet. There was a experiment of reinforcement learning via pigeons. So what they do, they trained their pigeon, the pigeon. It was pigeon, of course. So they what they do, there was a box. That pigeon was supposed to hit it onto the some say yellow color part circle. They show them that box, cardboard basically. That pigeon will hit it. Now if they hit it right, they feed pigeon. If they hit it somewhere else, they do not feed it. In fact, so that's the penalty. So feeding is the reward, not feeding is the penalty. So what they observed over thousand such kind of attempt, pigeon at the end, pigeon was just hitting onto the right yellow parts of the cardboard. So that's what reinforcement learning, where you make your system learn based on your interaction with the environment. That's how self-driving cars or robotics learn. You take wrong step, you are penalized. You take right, you take right turns, basically the right step, you are you are rewarded. And over the process, over the policies, by policy means that some strategies which are decided over the different trial and errors, you make your system learn. And that's how ADAS, self-driving car systems, are trained. They learn in the real environment, right? This is known as reinforcement learning. Most of the cases, in our cases, when we for the type of companies we are working, we hardly, or maybe one or two project we would be working on reinforcement learning. Most of the times our use cases are from the supervised or unsupervised. But what if we are working on some agents? Yeah, so reinforcement learning is used. One of my teammate in my team, they are working on one of those solution via reinforcement learning. So you do see reinforcement learning, but in startups like not startup companies like Amazon, Facebook, even the Tesla, they are totally into reinforcement learning, of course. So other than reinforcement learning, many more, but reinforcement learning is there to make their cars, robots learn how to behave in the system. Overall, these are the three categories: supervised, unsupervised reinforcement learning. 99% of the problems would be solved by the supervised and unsupervised, and some of the problems which in our in domain like manufacturing, reinforcement learning is also there. So this is the three broad categories of machine learning. Now in the next session, now there are different algorithms and inside these things. So what type of unsupervised machine learning algorithms, similarly what kind of, so I'm got in this whole by the end of maybe in next 10-12 classes whatever planned, we would be just focusing on the supervised, unsupervised. We can discuss reinforcement learning, but we will not go deep dive into that. We will skip this and we will jump to the Gen AI, the chat GPT thing. So yeah, lastly, just to summarize how a normal machine learning pipelines looks to you. So when you create a machine learning pipeline, you have the data, right? You cannot use your data directly because data in actual scenarios do not come up in a clean way. When I say clean, the customer provides your data. Sometimes the data would be lesser. You decide that whether you can work with this data. Some columns must be, for example, empty. They are nulls. They are null. They are non values. Some there are some data is there, but comma is there. So there are many things which we are supposed to be taken care of. So we do a kind of thing known as pre-processing. Basically, processing your data before the training, right? Once this is done, we train our model. When I say training model, is the using machine learning algorithm, given the data, given the output. I have mentioned futures underscore labels. So futures means independent variables, labels means ground truth. Given this set of data, understand, train the model, find the patterns. Once you do that, once you do that, uh, uh, this is some kind of evaluation. Now, one data point comes up, same data point will be processed the way we process, and it would be fed to the model, and model will give you the inference. Inference means giving the prediction. So these are three terminologies you will read a lot: pre-processing, training, and inference. So training and inference. Inference means giving the predictions, finding the predictions. Your model is trained. This is ready. Now, when any data query will come up, model will take this data query, and based on the learning, it will give you some predictions. For example, we trained a house pricing system. A new profile come up. I've for 3 BHK in some locations for this, what should be the appropriate rental? Model will look at this query and give you the predictions. That appropriate rent 40,000, for example. So this is how it works. So this is simple machine learning pipeline, and it always be more steps here, but every step lies into these three things. If you wanna train your simple machine learning, so when we gonna code, we for few algorithms we will definitely look into the code. I'll do it in front of you, and I'll share the code with you as well just to practice. I would be doing these three things only. I would be doing the pre-processing, training. There's one more thing I've not mentioned here: evaluation, which model is best, and then I take some query and then do the inference and finding the predictions. So this is a pipeline system design of a machine learning pipeline, right? So guys, any question? Three kind of algorithms and a high level view of this pipeline. Okay, so again, I'll
So,
share this slide.
sorry,
Yeah. Mhm.
right, Raj, one question. So, in in un in unsupervised learning, you mentioned that we don't know what the output is, right? Or the system will not know what the output is, and based on the pattern, sorry, but means the system has to identify a pattern, and then it will solve the problem. But uh, how does the logically, how do we know that we have arrived at the right solution? So do we always have to rely upon the evaluation of it, or do we have another supervised part which will be monitoring the unsupervised learning?
Okay,
Is it
so
something?
let's come to this slide. Yeah. So that's the right explanation. How do you identify whether you have come up with the right thing? Evaluation. So every model training never goes ahead with the evaluation on a data which is unseen. So for example,
Okay.
you collected data from the past, right? For example, I'm creating a solution. I collect data
Yeah.
from 2020 to 2025, for example. And now my model is ready. Now I'm gonna see how this model performs in 2026 January. I, now January is unseen, not in the model. Now I'll evaluate this model and see how I'll evaluate with the ground truth how well it performed. Now, if you've trained a couple of models, you will see which one performs better. So evaluation is always associated with the model training. So you cannot just train the model and give it to the system. No, because you do not know how it performs. You have to evaluate it, and this evaluation also happens at the time of training. So this specifically come into the model training, where model will learn. Okay, if I make a wrong predictions, model is would be corrected via mathematically the coefficients. If model makes the right predictions, model would be reward. Reward is not right word. Model would be made corrected if it makes some error. But overall, how is the model? You have to evaluate that for sure. And that happens on all the stuff. Unsupervised machine learning, and supervised machine learning, reinforcement everywhere. For example, let me give you one example. Uh, earlier, it's just let's go back to 10 to 15 years. There was no the how the exit poll used to happen. People used to visit. People used to visit different locations. They used to go ask people whom you gonna vote, and they collect the data. Even this is done even now, but sometimes we find that exit polls are totally opposite what they planned. Now, what could have gone wrong in that scenario, right? So here the human biases there. For example, if someone who was going to the people asking whom you will vote, they has some biases, and he just asked all the older person. So the results might they he never goes to any adult, maybe any working class people. So his collection of data was biased. So therefore his access poll of the news channel were totally opposite directions. Got so how you are grouping your data, that has to be evaluated in any of the problem. I'll give you one problem where you group the data. So for example, if you we are in Pune, and if we for the recent election, for example, if we want to find the exit polls and our people who visit the people who just say focus on one particular type of people of the PCMC, the exit poll would not have been the same what was the actuals. So how you are grouping your people, under what categories, that grouping has to be right. Now have you made the right, you would then evaluate it onto the unseen data, which you have keep it safe, so that we're gonna see how we train model, how we evaluate. And one system says okay, this evaluation looks good, we go forward with that. And never is the case that as the time goes, that same model will use. With the new data coming to the picture, we train it again. So that's what machine learning model training keeps happening forever. So you keep improving your models based on the data. uh, does it make
Got
sense?
it.
I
Yeah.
mean, yeah.
Yes. Yes. Got it. Yeah. Understood.
Okay, right. So okay guys, so this is last slide. What I try to capture here is that mostly the areas where the AI ML is applied, differences in traditional systems and versus machine learning, that's pretty much now understood to each of us. What machine learning is in simple term, I think you should be able to explain. And then types of machine learning, we see supervised, we have unsupervised and reinforcement. We would be just focusing on the supervised and unsupervised for now. Supervised are the ones where you know the ground truth, unsupervised are the ones where you do not know the ground truth, right? Next would be a Python programming. I will just on the next class, maybe it's gonna be on the next Monday. I'm on leave, so next to next Monday, but that's okay. That's Gita already discussed with Gita. So Python programming, this I'm gonna carry on hands-on with you all guys, and later I'll share this programming with you. Uh, and it would be from very basic to a decent basic level, so that in our semester exams programming, I'm not sure how this is going to conduct this time, this will help you. So I normally keep open book kind of in a programming test. I mean, because I nobody in 3 months the C++ guy would not be able to write Python programming totally from in just 2 months. So you can find the required code snippet here. So goal is to understand the machine learning rather than writing the Python programming. So, but still, one session is going worth before going to next classes. And
Um,
also, yeah, yeah.
Sorry, sir. So, do we need to install the Python
Mm-hmm.
before our class, basically on our laptops, or
So,
and do
yeah,
you
so
recommend any particular version?
I'll recommend something. So I will not recommend you to download Python. I mean, if it is in your system, you can do it very well. But what I'll do, we will. I'm office system. Google Colab is the thing. You search Google Colab. You click it here.
Yeah.
This is free. You can log in with your any ID, and your data not data, your code for whatever you write would be saved. And we will use Google Colab.
Okay.
Let's see. Yeah, this is open. For example, you can also create a new file. You can upload it into a notebook.
Mm-hmm.
Uh, for example, connect. I need to sign up with Google account. Once I signed in, I can write a code here. For example, print hello world, right? And we can and you this by automatically your code will also be saved. So no,
Right.
if you go with this, no need of having any setup in the system, right?
Yeah.
Later, so for
So
example, the code, just one thing, for example, if when I will do this hands-on, I share with you the notebook. This is called as notebook. So what you can do, even you can open your upload my notebook and run the code at your side. So that saves your time as well.
Yeah.
Yeah,
And
so it means in Google Colab itself, we can able to write
yeah,
in
yeah, yeah.
Python language, correct? That's what.
Yes, yeah.
Okay.
The code, every time if you click a code, a new tab will open. You write something here, and you either press Control Enter, Alt Enter, or you run. This is and this tells you how to do that. Basically they are trying to explain this thing. Remove all that stuff, make a fresh new notebook, and then it would be time. I'll show you, and then you can follow the same. See, they've already, the Google Colab has a very good content here. How to train a neural network to create a handwritten digits, or train a mini GPT language. So but that's okay. This would helpful for you later in your free time. But yeah, we will use Google Colab. And if anybody wants to do the Python setup, not required, but if required, let me know. I can do that. We can together do that.
yep. So one more question. For this course, basically, if you have something to read before every unit, maybe you can let us know beforehand so that we can have some idea about what.
Definitely,
Yeah.
definitely. Yeah,
So,
yeah. So this would be helpful. Yeah, I'll take care of that. So eventually, let's discuss the syllabus. So what I'll do for the next class, I'll just give you some topics, some specific topics you can read, so that we do not go deep dive into some YouTube videos and figure out that that's not useful. Okay, so this is gonna be the syllabus. Of course, the timings, everything would be changed. This is not updated. This is with respect to the previous batch. This is we have discussed right now. I'm gonna discuss the Python. Let me share the screen. Division of Python. Pandas is the library which is helpful to read the data in the CS3 Excel form. Heavily used. We're gonna see that too. And and once you start using pandas, this is gonna helpful you in a lot of things. You have no idea, and whoever knows, they knows. Then we will try to understand the basics of linear algebra, how the vectors are defined, matrices, options, basic statistics, stats, that what is mean, median, what is the normal distribution, etc. And then we're gonna start the linear regression, the thing which I mentioned. So this thing I will take on not 4 hours. This would be reduced. Whatever the required for the algorithm, we will straight away jump to the linear regression. We're gonna understand this algorithm. Then we're gonna go classification algorithm. Model evaluation. This is very important. How you evaluate a model, and then I'll take you to unsupervised algorithms. How to do the clustering, the grouping, basically dimension reduction. How to reduce from 100 variables to 20 variables, 10 variables, and then I'm gonna discuss the basics of neural network deep learning. Numbers not fixed. How neural network works, how the computer vision based object detection used to work, and then we gonna this would be increased. We're gonna use the LLMs, how you can leverage LLMs in your day-to-day life, writing the agents, and yeah. So that then there would be a case study. Finally, would be the assignment project. So in the last batch, how it was that there was first term, then there was an assignment, and there was then the last term. So this we will check. And then update you that how the assignments and project would be there, but just that's not required for now because that's not the goal to clear the exam. Just try to get the fundamental side is the essence of this course. Okay guys, so that's the plan. So we will meet next week and I'll share the this lecture with you uh, tomorrow, by tomorrow or by Monday. Mostly I'll do it right away. I'll do it today. I just need to know where to send these chapters. So Krida,
Yeah,
is
you
there any
can.
is there, yeah, here itself?
Yeah, so I think you can send it via the email which I've sent you. So everybody's copied in that. And then
Okay, okay,
we are
understood.
maintaining a
Hmm.
drive where we will upload
Okay,
it.
understood. Perfect. So I'll do it that way. Hmm. Okay, guys. Then yeah, then see you all the next class whenever it is, and then yeah, good night. Then
Yep. Thank you.
yeah, take care.
Good
Bye.
night.
Yeah.
Bye
Thank
bye.
you.
Thank
Thank
Good
you.
you.
night.
Bye bye.